Hey guys, welcome back to this lecture, Understanding the Basic Architecture and its Components. Here we will learn about the basic architecture and we'll see how the different component works in this Prometheus ecosystem. Okay, on the screenshot, you can see in the center we have Prometheus server, which is the core unit of your ecosystem, and it is the only place where all the processing and scraping work occurs. As you can see, Prometheus server is having three boxes inside: retrieval, TSDB, and HTTP server. Retrieval is basically which retrieves or scrapes the metric data from your targets. TSDB is the storage of Prometheus server, that is time series DB. It is the default storage which comes with Prometheus server. And the next is HTTP server, which is basically used by the web UI to expose the UI to the public. Below that you can see the node or SDD SSD. That means your Prometheus server by default stores its metric data into the local file system in the form of files. We'll learn about this storage in depth in the succeeding lectures. Okay, the next you can see the Prometheus server also pulls the metric from push gateway. You'll learn about this push gateway. What are these? How does this work? The next is alert manager, which is basically used for alerting, and Prometheus server is the central component which basically sends the push, or which basically pushes the alerts to alert manager for the alerting. The next is service discovery. It works with Prometheus server to discover the targets, right, based upon the configurations. And the next is the visualization part. Again, Prometheus server works with these visualization tools to provide the more interactive and more rich information graph. Okay, now I'll explain a bit in depth about these components, the major components, and then throughout the course we will learn the technical perspectives. How do we implement and configure them? So let us go a bit into the components. Okay, now the first you can see Prometheus server. So Prometheus server is the center of Prometheus ecosystem. This is where all the processing and scraping work happens. And by default, it uses TSDB to store metric data and stores the data in the local file system in the form of files. We already discussed about it. It has its own web UI and supports alerting rule for alerting, right? And one thing I missed here is the PromQL. It supports the PromQL to explore the multi-dimensional data of Prometheus. Now next we have alert manager. The alert manager handles the alerting part of Prometheus ecosystem. It supports deduplication, grouping, routing, inhibition, and silencing of alerts. I'll explain a bit about these terms. Deduplication is nothing but sending you a single alert if you are getting the multiple from the different Prometheus servers. Let me take an example of this. Now suppose you have a high availability cluster of Prometheus. So how you provide the high availability? You can have the multiple Prometheus servers running in parallel which are scraping your same targets. What is the purpose of that? If one of your Prometheus server goes down, the other Prometheus server will still be up and it will be scraping those targets and sending the alerts to alert manager, right? So now multiple Prometheus servers are running. Suppose in your target any event or incident occurs, so all the Prometheus servers will be aware of it. All the Prometheus server will send the notification or will send the alert to alert manager. Now it's responsibility of alert manager to identify, okay, these three alerts are same, and now I just need to send a single notification for this. So this is deduplication, and yes, alert manager supports that. Next is grouping. So it's a good part about alert manager is that whenever you see the alert or the notification which alert manager sends, it contains the incidents occurred through or in that time. So it basically groups the incidents into one alert notification, then sends them over the medium whichever you have configured. Routing, okay, as per your will you can route the different alerting to different mediums. Like suppose you want like low priority alerts or low severity alerts should go to Teams channel, and high priority alert go via email to the particular recipients. So this is you can configure in your alert manager. The next is inhibition. Inhibition is the mechanism to prevent the one kind of alert in case the second kind of alert is occurring. Now suppose in your monitoring system you have implemented a rule where you are saying if my cluster is down, then I should not receive the incident down in that cluster notifications. Means you know your cluster is down, you don't care about the internal incidents until unless your cluster is up, right? So you just want to see the one notification for cluster down. You don't want to see the other notifications belonging to that cluster. So this kind of inhibition rule you can create in alert manager, and it very well supports it. Now the next is silencing of alert. Means you can silence a particular kind of alerts in case you are already aware of it. So you can set up the time and you can set up the description of that silence. So once the silence period is over, your alert manager will again start sending the alert for that particular incident. Okay, the next is it supports email, PagerDuty, Obsidian, and many other integrations for alerting. Yes, you can integrate different tools for the notification apart from these three in the screen. You can also integrate Teams, Slack, and few others. We'll see it throughout the course as well. We'll integrate Slack and Teams with the alert manager. Now the next is push gateway. Push gateway again we have already discussed, but I will explain a bit in depth now. Push gateway allows you to push metrics from jobs which cannot be scrapped. Now suppose you have a Python code you have written which runs every 15 minutes, right? And then it goes down, and then again after 15 minutes it comes up. It basically does this very simple task and then goes down. Now you don't want to instrument it with your code, right? And you cannot implement the service discovery for such kind of jobs. So what you can do, you can use the push gateway in those cases. So your short-lived jobs or the jobs you are using, those jobs will export the metrics to push gateway, and then from push gateway it will be scraped by the Prometheus server. Now in push gateway there are few drawbacks as well which you need to take care of, and we will learn about this in the proceeding lecture as well. From the upper layer, I'll say you should use the push gateway only for those jobs which are not semantically related to service machine or job instance. It will reduce the burden of managing stale metrics. This means push gateway by default does not forgets anything that is coming its way. So it works as a caching, metric caching. It stores the metrics whatever came to it, and you'll have to delete it manually if you want to, right? What happens in that case? Now suppose your short-lived job goes offline now, and now then next a new job comes up. If your job is having a particular instance IP or job instance ID in the key value pairs or in the labels, so it will create the stale entries into your push gateway, because every time a job comes up a new series will be created. So you will have to manually clean those series into the push gateway. So this is why it is recommended you should use this for those jobs only which are not having any unique identifier, right? So these should be the common labels which your job should have. Okay, the next one is exporters. These are the libraries and services which helps in exposing the metrics. Okay, it is useful where it is not feasible to instrument a given system directly with Prometheus metrics live directly. What is the meaning of that? Now suppose you have a MySQL server and anyhow you are not able to instrument it with your Prometheus library or the client library available. What you will do in that case, you can use the MySQL exporter which is already available in the Prometheus ecosystem, and you can expose the MySQL related metrics to Prometheus. Now some of the exporters are maintained by Prometheus GitHub organization and marked as official, while others are externally contributed and maintained. Yes, There are few exporters which are officially provided by Prometheus GitHub organization, and those are marked as official. And there are few others third-party exporters as well, which are contributed and maintained by isolated or individual developers, and you can use them as well. Okay, and the next is client libraries. These are nothing but the code snippets which you can embed into your application code and can expose the metric via an HTTP endpoint. The following client libraries are available officially: Go, Java, Scala, Python, Ruby, Rust. And apart from these, there is a huge list of libraries available for other languages as well, but these are third party. Service discovery is the mechanism to automatically discover the target based on the configuration. Yes, it offers a variety of service discovery options for discovering scraped targets like Kubernetes, console, etc. Apart from this, there are many other configurations as well which we will be using throughout the course. Like we will be automatically detecting the EC2 machines, we will be implementing the service discovery over MSK and others. Third-party tools. Yes, there are a lot of third-party tools available in the Prometheus ecosystem, and we'll be using it throughout the course. So this was about the architecture and its component. I hope it was helpful to understand the basic things about Prometheus. Now I'll be wrapping this lecture here. I'll see you in the next lecture.